because I think those have real implications for coaches. If you know the fiber type composition of your athlete, you already know how to manipulate your training variables. Whereas if you want to, like if a new athlete comes to you, you probably need some time to know this training method works for this athlete. You probably need a few years, but maybe if you would have known their fiber type composition, that could have already put you in the right direction.
Welcome to another episode of Exercise Inside Out, episode number 22. And it's again the second episode in English language for all our German visitors. And I'm really looking forward because I'm not alone. For episode 22, I brought Freek Van de Casteele with me from Belgium. So let's see. Episode 22 is about to start, and today we will have a very special topic that covers basically from the fundamentals to the most implied parts, and the topic is muscle fiber typology. Freek, I'm glad that you are here. You took the train from Belgium and you are just in time. No train delays, even for German trains.
Yeah, I was really surprised and delighted as well.
Yeah, so great having you for this topic. We have 4 different chapters, so to speak, that we want to cover. First of all, we want to see what kind of muscle fibers do we have, what kind of fibers are there, and cover a little bit about the basics about muscular structure and fiber types.
Yeah.
Then my next question would be, how are muscle fibers related to exercise performance? What about sprinters? What about endurance athletes? What about team sport athletes who basically cover both? Third question will be, very much in the direction of your research topics. How can you determine muscle fiber types? Spoiler alert, there are several different possibilities to do that. And last but not least, we will talk about how can I personally change my muscle fiber types? How can they be altered due to training or even inactivity? And Freek, I really like to talk with you about these interesting topics.
Yeah, I'm looking forward to it.
Okay. Great. So, in the beginning of every Exercise Inside Out episode, always if we got a new guest, we start off with something that is a little bit off topic, but also interesting. You will now face the category Speed Meet with 10 questions, the only 10 questions that we not discussed beforehand. Are you ready?
I hope so. Let's do it.
As ready as can be. Okay, so just try to answer the questions as fast as possible, but just if you need to think about it, it's totally okay, but just what comes to mind. Okay, first question, tea or coffee?
Coffee.
Okay, definitely
coffee.
Okay, I think it was the first thing that you've mentioned after the train ride. Where can I get a little bit coffee? Okay, great. Traveling or running?
Ooh,
gotcha.
I like both, but traveling, yeah.
Okay, so if you just have to quit the other for the rest of your life, quit traveling or quit running?
Quit running, I'd say.
Okay. Yeah, I have to mention it.
I also like different sports, and I don't want to stay in Ghent for the rest of my life. Forever.
Okay. Yeah, so, but you like both?
I like both, a lot.
Good. Okay. What's your favorite comic? Do you have a favorite comic? Because I know comics are quite...
like comic book? Or?
Yeah, like I just mentioned this because I think in Belgium comics are way more famous than in
Not
Germany.
really a big comic fan. I don't know. When I was younger, I liked South Park, but
yeah, that's definitely something. Yeah, I think the South Park is okay.
Yeah.
I can work with this. Surfing or snowboarding?
That's a difficult one because I enjoy both, but I'm much better at snowboarding than I am at surfing. But I would say surfing. Yeah,
surfing because of the ocean,
the weather. Yeah.
Okay.
But I still have to get much better. I'm not really good at it.
I've seen you surfing and snowboarding on Instagram, so this is why I thought like he has to decide what's better. What's your secret superpower? Do you have a secret superpower?
It's a hard question.
That you're very famous for in your lab or outside of the lab?
I don't know. I can drink many coffees on a day. I don't know if that's a secret superpower, but
I can take. So your
caffeine tolerance is high.
Okay, good. How many coffees do you have on a day where it's maxed out?
5. So it's not that bad actually.
Okay. Yeah. Okay, impressive. Pizza or pasta?
Pasta.
Pasta. Okay. What's your favorite city in Belgium?
Ghent.
Why?
It's one of the most beautiful cities in Belgium. The churches and just the city in general, the streets are amazing. And I've studied there during my bachelor's and master's, and I'm doing my PhD there. I've been living there for a few years, and I really enjoy living there. Yeah.
Can't be too bad if you studied everything there and not after the bachelor degree said, okay, I have to quit.
No, I like Ghent a lot. Yeah.
Okay, great. French or Dutch?
French. It's a much more beautiful language, although, I mean, Dutch is my mother tongue, but French is nicer to listen to.
You like French more?
Yeah.
Okay. 2 questions. Question number 9, low intensity or high intensity?
Difficult one as well. Let's say high intensity.
Do you like training for high intensity more than low intensity?
I like both, but I think the feeling after a really tough high intensity workout beats the feeling of a long low intensity one.
Okay, great. And last question, type 1 or type 2?
Type 1.
Why type 1?
Just because that's my my dominant fiber type in my muscles. So
okay, great. So out of speed meet, we now have the first conclusion. We got 2 different fiber types. We will talk about their differences and their distribution among different spots in just a minute. Before I think we can just elaborate a little bit more about your career. Why are you an expert on muscle fiber typology? And from what I've Googled and what I know, since we've met in Sevilla in 2022 with Yannick Schwarz and having a run on the, I think, was it the run? The Ghent run?
We met before, but then we did the run together somewhat.
Yeah. I think Yannick wanted to talk with you because you did this interesting research about different muscle fiber typology methods, and I think this was the first meetup von der Tour. And we did the Ghent run as well. Did we run together?
I think we started running together in a little group, and then at some point I got lost on the track, and I got up with you guys, and then I had to let you guys go in the last few hundred meters.
Yeah, it was until now the best 5K trial of all of my running career, and it was the one that I prepared the least for. So maybe it was just maybe some fiber type shift beforehand because of inactivity. I don't know. Okay, so you already mentioned that you have studied in Ghent, in Belgium. Is it in Flanders?
It's in Flanders, the Dutch-speaking part.
Dutch-speaking part. And you studied your bachelor degree, your master degree, and now you are in your PhD and will hopefully finish it this or next year.
Yeah, it will depend a bit on funding, but it will probably be sometime in 2025 that I finish the PhD, or at least I hope so. And yeah, as you said, I did my bachelor's, master's in Ghent, and now I'm doing my PhD in the lab of Professor Wim Drave, and working mainly on how to measure fiber type composition in humans, also looking at non-invasive techniques, and then seeing what fiber type composition, what it actually means in sports performance. Are there different ways to apply it? So that's actually what my PhD is on.
Yeah, we just had a chat in one of the famous Cologne restaurants, and you mentioned that your PhD is basically covering a huge range from very fundamental research on muscle fiber typology and methodological research up until how it is applied and how does muscle fiber composition relate to match performance, maybe pacing in your lab as well, and different things. So I think this is a great opportunity for me as a podcast host, having exactly that in a podcast episode, from the basics that we want to cover up until how it is transferred into practice. So thanks again for coming here and having a chat about the different parts. When did you first came in contact with this interesting topic about muscle fiber typology?
So in our masters, we had to pick if we wanted to do a minor in research, education, or sports management, and I obviously picked the research one. And my research was already on determining muscle typology in soccer players via a non-invasive way that our lab was using, and then seeing how that impacted their match running performance during games. And I picked up on that topic during my PhD.
So this is when you fell in love with this topic and it got stuck.
Kind of, yeah.
Okay, yeah, great.
It always, really inspired me.
And I think one of the great, a great value out of your lab or of your research group, of how to translate research findings into practice for those of you who want to have a perfect booklet about this podcast episode. I can highly recommend the booklet of Eline Lievens, which we also met in Paris, because she's done a PhD in terms of myotypes, the relevance of muscle fiber typology in sports. And this booklet basically covers a lot of things that we are going to discuss about. And you will also find a link to the booklet, which is a free PDF, which is great, in the show notes, where you find every single study and every detail and links to your social media as well, as we will discuss. And one of the things that might be relevant before we come to the muscle fiber typology could be how muscles are built in general. What is the main structure? Because if we now talk about muscles, I always have this kind of idea in mind. Do you know what it is?
Yeah, I know there's multiple smaller ones inside.
Multiple layers. So, for example, if we talk about a muscle, and if we now take a closer look what is inside of this muscle, then we have the muscle fascicle. So, again, something very similar, but rather smaller.
Yeah, and there should be multiple in there.
Yeah, and should be multiple in there, but there's just one fitting here. And if we now come even closer, we come to the muscle fiber. So every single muscle fiber that can be of a certain type. And if we now, and I think I can't do it, but if we now get even more in depth, then we have the different filaments, which is actin and myosin. And so what kind of isoform of these myosin we got is basically one of the determinations of what kind of fiber type this is, but just having all of the time smaller particles or parts of the muscle that in the end determine what kind of fiber this is. So we don't have muscle types, but rather muscle fiber types.
True. It's a type of your cell, and traditionally that has been determined with quantifying what the myosin heavy chain isoform is. And in human skeletal muscle, there's only 3 different sorts. You have type 1, which is the slowest isoform. Type 2A is fast isoform, and type 2X is an even faster isoform. There's also type 2B, but that's not in human skeletal muscle, but you can find it in other animals like mice and rats. Yeah. So 3 types, but then you also have fibers that co-express different ones, so at least 2, and that's what we call hybrid fibers.
And these hybrid fibers, so I think there are also different kinds of hybrid fibers. So you can have a hybrid between type 1 and type 2A. You can have a hybrid between type 2A and type 2X, which is the fastest one. And I've read there are also types where all of these are related. But is it really, can you really determine these kind of...
You can determine it, and I've also read some papers that report some of these fibers, but I think it's really rare. And I think, if that actually exists and it's not some kind of methodological error, that we don't know what their actual function is,
So these are not researched in such a detail because they are very rare.
Yeah, so you would only, like, if you would determine fiber type composition on hundreds of thousands of fibers, you would maybe find 1 or probably none or a few. Yeah.
Okay. We will discuss about how these fibers are related to exercise performance, because they are relevant, and even coaches, if they had the opportunity, as it is written in the booklet, they asked, I think, 500 or more than 500 coaches, and what she pointed out is that roughly 90% of the coaches would actually like to have their muscle typology being determined, and even up to like 80.4% would be actually willing to do biopsies for doing this. So I think the relevance of muscle fiber typology is there. There is a need, and since it is related to performance, I think it is relevant to know what are the differences between these fibers. So we already know that there are 3 different basic types, aside from the ones that are a mixture. And you already mentioned that type 1 fibers are the slowest, and type 2X fibers are the fastest. What kind of other differences can you mention between these 3 different fiber type?
So because of the maximum contraction speed that's already higher in these type 2 fibers, they can also produce a greater maximal amount of power. That's one. And then the type 1 fibers, so the slow ones, they are much more fatigue resistant. Like if you stimulate them, they can keep their max power for hours on end, so to say. Whereas the type 2 fibers, the fast ones, like in minutes, they decrease their max power by a lot. So fatigue resistance is another one. max power, contraction speed, and then also the efficiency of an isometric contraction. Type 1 fibers are more efficient to produce an equal isometric contraction compared to type 2 fibers. They need less ATP.
Okay. So from what you've mentioned, I think the listeners might get the difficulty in terms of fiber types, because you can't really say this fiber type is better and this is worse, because it highly depends on the task that you want to fulfill. So if you want to have a really fast movement where fatigue is not the most crucial part, like sprinting 100 meters without pacing, without anything, then you highly rely on these type 2 fibers, and you really need a lot of them, because they can twitch, I think, double the or more than twice as fast. Obviously, depending on type 2X or type 2A, because I read in the literature that for a slow for a type 1 fiber, the time that they need to twitch is like 90 milliseconds, and for a fast muscle fiber type, it's like 40 milliseconds. So it's more than twice the velocity. Power, because power is the product of force times velocity, is depending on the fiber type 5 to 8 times higher. So this is why for sprinting, I guess it's obvious that a high percentage of fast muscle fibers is crucial. But it comes to a certain disadvantage. One advantage is it's less efficient.
Yeah, so but you don't really care about that in sprinting.
Yeah, obviously, yeah. So you don't really care about this. But from what I've read, but you can definitely tell us more of the details. I've read that the type 2 fibers are more prone to injury because the type 1 fibers are more stable. And I was like, how can this be? Because the type 2 fibers have more power. They have they are more related to sprinting, high forces. Why are these muscle fibers not more stable and more prone to injury?
Yeah, so some of their structural elements are a bit less robust, so more fragile in the fast twitch fibers, such as their Z discs or their titin is less elastic. So there are these things make that these type 2 fibers are a bit more fragile. And if you add that they can produce more power or much more fragile, then it seems almost logical that they're more prone to injuries. And so if you would look at that from a whole muscle perspective, then you could say that if this muscle has a high percentage of fast twitch fibers, it might be more prone to certain muscle injuries. And that's also what my colleague and current co-supervisor now, Eline Lievens, has shown in one of her studies in soccer players. Yeah.
Can you elaborate on that? So she analyzed soccer players and...
so this was in 2 cohorts. One cohort from the Belgian First Division and then one cohort in the English Premier League. And we determined fiber type composition in a non-invasive way. We can elaborate later on how that actually works. And then we categorized the players in slow typology players, intermediate typology players, and fast typology players. And what Eline found was that the fast typology group, that they had a 5 times higher risk of sustaining a hamstring strain injury. So that was the injury they were looking at. And so how they did it was they determined muscle typology from the start, followed them up for 3 seasons, and then looked, how many injuries occurred in each group. And there's 2 mechanisms that we think are at play or might be at play. One is the one about the structure, so the fast fibers being maybe a bit more fragile. The second one is that they might be more fatigued at the end of a soccer game, because we already said that they're less fatigue resistance. And we also have another study showing that their match-running declines from first to second half are greater, which again would indicate maybe a greater fatigue in those players. And if these fast fibers in the hamstrings are more fatigued, and then you have to do a sprint, for example, at the end of your game, and then at the terminal swing phase, your lower leg goes forward, and your hamstring has to contract eccentrically. If they're fatigued, then they're structurally less strong, and you have to produce a large force to decelerate the lower leg. Then that's a call for injuries almost. Yeah.
Okay, so in summary, if we want to be fatigue resistant and we want to be efficient, like in endurance running, for example, we want the type 1 fibers. If we want to sprint, we want to be fast for a short period of time where fatigue is not involved, then we need more type 2 fibers. And interestingly, Eileen also mentioned that there is a difference in muscle fiber type composition even between species. So, for example, if we take a look at the rat, for example, rats are sometimes, or in some research groups, studied for muscle fiber typology. They have a lot of type 2 fibers. So the percentage of type 1 fiber is very, very low.
Yeah, exactly.
If you now take a close look, for example, in monkeys, then you find like a percentage of between like 10% to 50% type 1. And in humans, we have a huge variety. And for example, if you take a look at the sloth, then it's like most of the time 100% type 1 fibers. So really, really slow. But I think it's interesting that the human species developed this type 1 fiber distribution that can maybe be due to the hunting strategy that was developed during the evolution of our species. But there's a very, very large difference or variation, isn't there, between muscle fibers and how they are
in lots of animals, for example, the rats and the mice, you see that the muscle is composed of almost one fiber type. For example, in their extensor digitorum longum, it's almost all fast fibers. And then the human species, on average, you could say that they're a more slow type species on average. But then if you look at the variation is quite large indeed. That's what we see. Which this is really, really speculative, but could have had an advantage in during evolution that you had some different types in your type, but this is really speculative. Yeah.
To be adequately equipped for different tasks. So not only for the
persistence hunting, but also for having a quick leap on a tree if I want to get away from another species that hunts me. So but so we now know that there's a difference between species. There's the difference between our species, the human species. Is there also a difference between muscles? So are there muscles that you can mention that are on average, of course, individually different, but are there certain muscles more related to type 2 fibers and more consisting of type 1? Definitely. Like the most famous muscle for slow fibers is the soleus. The soleus muscle has like, if you would take just a random sample of people, you would probably find an average fiber type composition of between 70 to 80% slow twitch fibers. And then the upper body muscles are, or at least some of them are a bit more fast twitch, like if the triceps brachii, that's a faster one, would have like around 30-40% type 1 fibers. Yeah.
Okay,
So there's definitely differences between muscles.
Yeah, for me it's quite interesting because I work with athletes that have a spinal cord injury and are doing endurance training on their bike. I'm currently training Annika Zayen-Giles, which is the world champion and European champion in hand cycling.
Okay.
And for them, it's exactly, I would assume, the opposite, because they are doing a lot of hours each day endurance training for the upper body. So it would be interesting really having a upper body percentage of these athletes that train their upper body to a very, very high extent, like cyclists train their legs. So maybe we can have a discussion about having a single case or maybe
that would be interesting. Yeah.
Could be an interesting thing, and even the muscles that can't be innervated due to the spinal cord injury are interesting to see.
Yeah, exactly. I know there's some studies on cross-country skiers who also, of course, have to use their arms in endurance exercise, and they do find that they're a bit more slow twitch than the average Joe's triceps muscle. Yeah.
Is this mainly due to what they do, or is it genetically determined what kind of fiber type is more involved in your body? Is it genetics or is it environmental influence?
Yeah, that's a really interesting question that always pops up, and I think there's still no real consensus about it, but what I think is that there's quite a large part explained by genetics, but I also think that you can change it to some extent. Yeah, definitely by training or other manipulations. Like the people with their spinal cord injury, that's maybe an extreme case, but like the denervated muscles, they will probably have a lot of type 2 fibers due to the spinal cord injury.
Yeah, because the stimulus of the slow muscle fiber types need to be always active is lacking, or?
Yeah, maybe even the other way around. There was, for example, one study that looked at the gene expression of the type 2X gene. And what they did was they quantified mRNA. So actually the expression of the gene is what you quantify, and then also the myosin heavy chain isoform proteins. So then you've got the mRNA and the protein for type 2X. And they found that if you take a biopsy, there is some type 2X mRNA and protein in these people that they investigated. And then they let them do a few sets of heavy squats. And they could see that the expression of the type 2X gene was completely silenced, even up to 4 days after they did the exercise. So it seems that activity actually almost silences the type 2X gene.
I think for all the sprinters who are now listening, they now have a good argument for not warming up or cooling down after sprinting, but I guess just sprinting and then have a passive recovery and then sprint again. Sometimes this is exactly what you see in the athletics arena in the stadium, but on the track,
I think there's multiple reasons to not advocate for that strategy.
Yeah, so because blood flow is important, the muscle temperature should be higher, but to not, let's say, not extensively doing a 20 to 30K easy, steady, long run, if you are a 100 or 200 meter sprinter, is maybe not the appropriate.
No, that wouldn't really make sense, I think.
Okay. So now we are basically covering a few things of the second chapter, which is how are muscle fibers related to exercise performance. Eileen nicely illustrated that depending on the sport, we have different categories. So if you, for example, have these endurance sports, like, for example, canoeing, rowing, running, cycling, then you have more type 1 percentages. If you are more power related sports, like, for example, mountain biking, sprinting, or different kind of team sports, then you are probably more for the type 2 fibers, depending on what is the duration of the activity, how many rest recovery periods do you have in the match?
I think mountain biking is rather slow.
Rather slow?
Yeah.
Okay. Or down
regarding fiber type composition.
But maybe downhill cycling could be.
Yeah, that's a different ballgame, I think.
Okay.
But I was talking cross country mountain biking.
But there's also this intermittent profile, as you mentioned, for sports that have to cover both parts of the spectrum, or are in the mid part of the spectrum.
Yeah, I think already in the 70s, like the greats in exercise physiology, like Bengt Saltin and Dave Costa and Philip Golnick, they already characterized the fiber type composition of really high level athletes, and they already saw that like all the high level sprinters, they have lots of fast twitch fibers, and on the other hand, the high level long distance runners, they have a great percentage of slow fibers, which could mean that to become an elite athlete in a certain discipline, or at least for some sports, you might need to have a certain fiber type composition to be able to excel in those sports. And then the next question you could ask for the sprinters is, faster always better, or can you have like a certain range? Or same for the long distance runners, is slower always better, or do you just need to have a certain percentage, like up from 60% slow twitch, for example, and then you're good. And from what we see in the literature, it's not always as clear, but it seems that for long distance running, and this is also what we find for the non-invasive, with the non-invasive measure, that you're good from a certain threshold. It's not exactly clear what it is, but it's not that the ones with 90% type 1 fibers, if that even exists, are better long distance runners than the one with 70% slow twitch fibers. And with our non-invasive techniques, we do see that the 100 meter sprinters, that they're slightly faster than the 200 meters and slightly faster than the 400 meters. So there it might be that faster is always better. But yeah.
Okay, so you mean, if I understood it correctly, the percentage of type 1 fibers does not correlate with long endurance performance? So
it's just that we see that also with performance is more so like the biopsy studies from a long time ago. And then what we saw was that like with the non-invasive measures, that there was not really a clear difference between the 5K runners or the marathon runners. Like they were all slow, but it was not the case that the marathon runners were slower than the 5K runners. But
for the sprinters, you found a tendency towards...
we did see that the 100 meter runners were faster than the 400 meter runners.
Okay, makes sense from an athletic perspective. What I think is I find most interesting, because that the sprinters have a high type 2 fiber percentage, and that the endurance runners have a type 1 percentage that is quite high. I think this seems basically obvious, so to say, but what I find most interesting are these differences in between, or the disciplines in between, like the 800 meters, for example, where you, or Eileen mentioned that you find this, some are more like the sprinters that are doing longer distances, and some are more, have a higher type 1 distribution, and are doing the same event. And if they are meeting up in the same event, I think this is then very interesting, and especially for the training. So how do you, what can you say about these middle distance events in terms of muscle fiber typology?
Yeah, I do think they're really interesting from a physiology a point of view. And I don't think you find the real extremes, but everything between, you find it. And it has an impact on pacing. This is a study that Philip Bellinger did, and he found that the more slow twitch dominant runners, that they benefited more from an even-paced race, which would usually mean faster racing times as well. Whereas the more fast twitch dominant guys, they would benefit from a slower race with a really fast last lap, if you're talking about the 800 meters, for example. So pacing is already something that comes into play. And then if you look at the preparation or training, there's another study by Philip Bellinger, and he recruited high-level middle distance runners, and he found slow typology and intermediate typology runners. This was for 1500 meter runners. And he let them increase their volume in the first week by 10%, second week 20%, 30%. And then he looked at their performance and measurements of fatigue. And then they did a 3-week taper. And he found that the slow typology runners, they almost didn't decrease in performance at all. Whereas the intermediates, they had a clear decrease in performance and were acutely fatigued, which indicates that the fiber typology might actually have something to say about your optimal training method or training volume.
So, in other words, the muscle fiber typology or the percentage of type 1 to type 2, the relationship in between, is related to the pacing strategy, which is very interesting because I think we talked about it in Paris. We did a study where we also measured a parameter that should indicate how fast you can utilize glycolysis, which is the maximum lactate accumulation rate. We call this now cLamax.
Where did the V go?
The V went down the road because if you have a V with a point above it, it would indicate that you have a volume that is changed. Yeah. But it's actually a concentration that is changed. So this is why we used, in my old publications, I always written the V with the dot above it, which makes no sense actually, but it was referred to the previous papers. But in our most recent paper, we sticked, and we are going to do this now with the cLamax. But it's the same parameter and the same procedure. And what we found is that when we analyzed the 5K time trial, and we determined differences. So we had a pacing cluster analysis. They did, so it were 43 participants, male and female, all did a 5K time trial. We clustered them. We had 3 different clusters, and we found that the cluster indicating a negative pacing strategy had the highest cLamax, so the highest lactate concentration. And but interestingly, there was another cluster, and this cluster demonstrated a positive pacing, but had the same finishing kick when compared to the cluster with the higher maximum lactate accumulation rate. So we cannot say that it is simply the finishing kick. Yeah. There was a correlation between the finishing kick, so the velocity increase of the last 200 meters when compared to the previous race. But it was, I think it explained about 15% of the variance. And
this was a freely chosen pacing.
Yes.
Like you didn't give them any instructions, just run the 5K as fast as you can.
Yes. So we instructed them, run as fast as you can. The time is the most important variable. But try to, if you have something left in the tank, then get rid of it in the last part of the race. But we did not tell them a certain pace, and then they can choose from that. They could freely choose their own pacing. And I think this would be then interesting of how, if we had their muscle fiber percentage, how this actually relates. So one, do we see the same? Can we replicate our results, your results? And the secondly, would be most interesting for me for future studies to come if the parameter that we believe is associated with glycolysis, probably related to type 2 fiber types, type 2A probably, or type 2X, if we really see this in the data. Because I think you did a study with muscle fiber typology and the 30-second win gate, and also the decline, the fatigue index of the 50-second 30-second win gate, and you found a positive correlation between the percentage of type 2 and the fatigue. Am I correct?
Yeah. So this was a study where I collected the data from, and we measured fiber type composition in 2 muscles and 2 biopsies each, just to get an as representative sample for the actual muscle fiber type composition of the lower limb muscles as possible. And then we related those to a whole test battery of non-invasive tests that the literature has suggested previously that could be related to fiber type composition. And as you said, one of them is the 30-second win gate, and then we measured different parameters: peak power, average power, the decline in power from your peak to the end of the test, which is sometimes referred to as fatigue index. And then we also measured blood lactate before the test, and then 3, 5, and 7 minutes after. And so one interesting finding is that the post-Wingate lactate had a high correlation with the fiber type composition with the type 2 fibers. So higher blood lactate, higher type 2 percentage.
Yeah. So I would be really curious about a study where we do the same for a shorter period of time, because what I was wondering is we actually do testings for the sprint just 15 seconds or 10 seconds, because we believe that if we do a 30-second test, then the glycolysis actually inhibits itself, phosphofructokinase, so the key enzyme of glycolysis should inhibit due to the fatigue, due to the high H+ ion increase. So it would be interesting if we still find this correlation, or if it is probably even higher, if we do like a 15-second sprint and not a 30-second. We should discuss this for future ideas, because the doing this 15-second sprint is obviously not a huge deal. No. Can easily do this.
No, just
your methods
for people who are active. That's exactly.
Yes, I think so. The methods that you use for determining muscle fiber typology are way more complicated than measuring lactate.
Well, the one we've been using for the last over 10 years requires an MRI scanner, which is already much more difficult to get access to than your cycle ergometer. You do or at least I think that's what you do, the 15-second sprint on. Yeah.
Okay, so I think we made a smooth transition to chapter 3. How can you determine muscle fiber types? We now know that these fiber types are related to performance. They are relevant for us. We know when we want to favor type 1, when we want to favor type 2. So now I think the question arises, how can you determine them? Can you give us an overview, just briefly, how it was done, or when was it first invented, so to say? And what kind of methods are there today, and what do you use in your PhD?
So the classical way to do it is using a Bergstrom biopsy needle, and that one was introduced by Jonas Bergstrom, obviously, somewhere around 1970. I think the first paper was 1967. And what you essentially do is you anesthetize the muscle of interest, and then you make a small incision with a little scalpel. So you go through the skin, through the fascia. There's a little hole in there, and then you can insert the needle. And with the needle, you can excise a small amount of muscle tissue. And then you want to analyze that muscle tissue for fiber type composition. And there are different ways to do so. One of them, the one which was probably used the most in the past, in the beginning, is that you cut really thin slices from the muscle and then you stain them for the ATPase enzyme, because we know that the ATPase enzyme is different for the different fiber types. And if you incubate them in either more acid or more I forgot the
base,
more base solutions, and then you stain them for the ATPase, they appear differently. You have like black, white, and gray fibers, and then that way you can count the type 2, type 2X, type 1 fibers, and then you know the percentage of those fibers. That method is almost never used anymore because it's really tricky with the concentrations of the solutions, and also it's a bit of, you have some shades of gray, and it's not really clear what the exact fiber type composition is for some fibers.
Yeah, you could ask if there's or you could question the objectivity, because for example, if I see 50 fibers in this picture and I see, okay, there are 20 that appear to me, or 25 that appear to me as white, then it's just my interpretation of this is supposed to be white, but because there are just not 3 distinct white, gray, black, but there are every shade.
I mean, there are more objective ways of doing it with the microscope and then the intensity of the signal, but it has been done that way most of the time. And then another method is you do the same. You do the cutting on the thin slices, and then you apply antibodies that are really specific to the myosin heavy chain, and then you make an image again of those slices, and then you see which ones are which type. The advantage of that one is that you can capture lots of fibers. One disadvantage is that you have a really thin slice of your already small piece of muscle tissue. And then another method is based on the molecular weight of the myosin heavy chain isoforms, because they have different molecular weights. And then you can separate them according to their molecular weight using a gel. It's called gel electrophoresis. And then you have these typical black bands for each of the myosin heavy chain isoforms. And then you quantify how dense these bands are, and then you put a certain percentage on it. And you could do that for either a part of the muscle tissue that you make into like a kind of soup. This is not the best way to describe it. Or you could also dissect all different fibers, and then you know exactly for that fiber what the exact composition was. And that's actually the gold standard method, is dissecting the fibers, and then for each fiber individually you run the gel electrophoresis, and then you know, okay, this exact percentage of type 1, 100% if it's a pure one, or maybe 60 and 40 if it's a 60 type 1, 40 type 2A if it's a hybrid 1 to A fiber. The disadvantage is it takes a lot of time to dissect all those fibers, and even if you do a lot of them, you only have maybe 100 fibers. That's already a lot for dissecting for one person out of the multiple hundreds of thousands of fibers in your whole muscle. So that's actually one of the disadvantages of the biopsy method, but that's still the gold standard.
Okay. And I think you worked on implementing rather new methods, because for all of these methods we need a biopsy. Am I correct?
Yeah.
And we do different stuff with it, but biopsies have also a risk. Simply put, we cut a little bit of muscle out of it. Imagine we have elite athletes who are doing really precise workouts. Even if it somehow deteriorates their performance, they probably won't do it or are probably curious about it. So I think the question arises, are there more applicable possibilities or methods that don't require cutting some part of the muscle out of the...
I mean, just to be clear, if you do it in a research setting, it's like 99%, it's really okay, and it's only a small piece. But you do get like a really minuscule scar, and you're a bit sore for 1, 2, or a bit more days, but then you shouldn't have any issues afterwards. But I agree that with elite athletes, you don't want to risk anything. So that's why one of the studies of my PhD focused on non-invasive techniques. And in my study, we covered a lot of them. But like the past 13 years in our lab, we've been using one specific one that I already mentioned briefly that requires an MRI scanner. So what we do is we place the participant or the athlete under the MRI scanner. And then we look for the muscle of interest. For example, we regularly scan the gastrocnemius and soleus muscle. And then we place a voxel in there, which is an imaginary box. And that actually indicates in which volume you're going to do your measurement. And so when we perform the scan, what the outcome is a spectrum. So you have all these different peaks. And these different peaks are related to metabolites in the muscle. So in that volume that you specified on a monitor for operating the MRI scanner. And so then we look for the carnosine peak. And why do we look for the carnosine peak? Because we know that in fast twitch fibers, the carnosine concentration is about 2 times as high as in the slow fibers. And so we found that there's a really good relation between the fiber type composition and the carnosine content. And so that's why we use that as a non-invasive estimator. And so then we have the spectrum, and then we can quantify the concentration of carnosine in that muscle that we investigated. And the reason why we like this method is because it's at rest, and the carnosine concentration is not really influenced by training. We do exclude vegetarians and people who used beta-alanine in the past because that does influence your muscle carnosine concentration, and then you distort the relationship between carnosine and fiber type composition.
How does this relate to the carnosine levels? So if I'm a vegetarian, are my carnosine concentrations lower, and why? Or are they higher?
If you're a long-term vegetarian, meaning like multiple years, then it will probably be lower because carnosine is present in meats, and then you don't get the beta-alanine, which is the rate-limiting factor of carnosine, because carnosine is composed of beta-alanine and histidine. 2 peptides, and that's why. And then if you take beta-alanine as a supplement, you will increase your carnosine concentration in the muscles.
Okay. And you mentioned that the carnosine levels in type 2 fibers are twice as high as for type 1 fibers. Is there a difference between type 2A and type 2X, or is it not possible to differentiate?
I think so. The studies that investigated this were on single fibers, and I think they didn't differentiate. But actually, one interesting point is also that pure type 2X fibers, so only the type 2X myosin heavy chain isoform, that those are really rare and almost completely absent in healthy individuals. The reason why in the literature you can find all type 2X fibers, 10%, 20% of the fibers, is because it really depends on the method. If you will find these type 2X fibers or not. If you dissect the single fibers and then you do the molecular weight, then you will almost never find type 2X fibers. If there's type 2X in there, in the fiber, it will almost always be a hybrid type 2A, type 2X fiber. But like, for example, if you do the gel electrophoresis on your little soup of muscle tissue, then you just have a percentage. For example, 50% type 1, 40% type 2A, and 10% type 2X. But you don't know from which fibers those percentages come from. It's just an average of all the fibers. So, yeah.
Okay, but again, it's important to mention that the method is crucial for interpreting every single outcome. So if I just say like, okay, my percentage is like so, and so, the first question should be, what was the method of the methods that you mentioned? Is there an agreement on what is the gold standard?
Yeah.
Is there a gold standard method, or
the single fiber SDS page? So based on the gel electrophoresis, that's considered the gold standard. It's just that the real disadvantage is you can only do it for so many fibers, and usually it's not more than like 100 per individual is already a lot for those type of studies, because it's just so labor intensive to manually dissect those fibers.
And the methods with the MRI and the carnosine peak. How good is this method? How does it relate to the gold standard outcomes?
There's a good relationship. We've done, or we've published 2 studies in which we had both biopsies and carnosine, and then the study I did is not published yet. The one from Audrey Baguet in 2011, I think, was like an R² of 0.50, so explaining 50% of the variance, which is not everything, but comes close. Not to everything, but it's already something. And then in Kim van Vossel's study, I think it was even higher or something similar. And then in my study, it was a bit less. Yeah.
Okay, so the agreement is about 50-60% from the goods?
Yeah.
And how do you consider these 50 to 60%? Because maybe some listeners who are not aware maybe say, okay, this is not much. But from your perspective as an expert, is it considered to be a good agreement, or is it... Because
it has 2 sides. Like for me, it's a moderate to good agreement, I would say, or actually a good one. But what we have shown again and again and again in the papers is that it does have relevance in sports performance, the carnosine measurements. So I think we validated that in that sense. And then the second thing you have to consider as well is that the biopsy-based method is not perfect either, because you're only looking at a small amount of your complete muscle. So you actually, with the biopsy, you also make an estimation of the complete fiber type composition of that muscle. And when we take multiple measurements in the same muscle, we also see that it varies a bit. So this is actually one thing I've been struggling with a bit to wrap my head around, is that you're already working with a gold standard that's maybe not so gold.
It's a standard.
Yeah.
Yeah, but you don't know what the measurement error of the gold standard is. So this is why it's hard to say that this is exactly what it is. And
well, you do know the variation between taking different biopsies in the same muscle, and that can rate. Like if I take 2 biopsies in the same muscle, the difference in percentage points can go up to like 20 percentage points. That are like some of the highest values you could find. But like a difference of 5 is like, that's really common. So there's a lot of variation. So that's what I mean with it's not the gold standard.
Okay, so even if it's if it is super interesting to see the percentages, knowing that replicating a biopsy, taking another sample with other fibers can lead to up to 20% difference.
Yeah.
I think is quite a big deal.
Those are all. I mean, those are the highest differences, of course, that we find, but they are possible. I lost my train of thoughts. That's also why you might see, for example, in these classical studies or in other studies, like 95% of type 1 fibers. I don't really believe that whole muscle has 95% of type 1 fibers. You probably just picked the spot where there's like a lot of type 1 fibers, but maybe if I took another one, it would have been 80, for example, or 85.
Yeah. Is there any data on the position of the sampling? So, for example, if you take the vastus lateralis, so the lateral part of the quadriceps muscle, is there a systematic difference in muscle fiber typology that, for example, the distal part of it is more type 1 than compared to the proximal part? Or is it depending on the sport? Or is it just randomly, but there's a variation, but it's more or less random?
It's random. Like, it doesn't really matter if you go more proximal or more distal. There is some research, this is in cadavers, where they test like the depth of the site. And it might be important to standardize the depth of the biopsy site, because it seems that, for example, in vastus lateralis, the more superficial fibers are a bit more fast compared to the deeper ones. And then if you look at this is already from, studies in the 70s as well by Elder and colleagues, and then they also did it for the tibialis anterior, and then it was the other way around. So I don't really know why, but so maybe it has something to do with the function of the muscle. I'm not sure.
Okay, so it's not simply the more superficial, the faster, and the more.
It was in the vastus lateralis, but not in the tibialis anterior for some reason.
It's not the same for across all muscles.
No.
Okay, but it depends. So it's important, but it's not.
Yeah, well, the best thing you can do if you do studies with biopsies is just to standardize the depth and try to have it the same for every participant. Yeah.
As with any other study in every other topic, I guess, having this standardization. Okay. Is there something you want to add regarding the different methods and the agreement between methods before we come to the last question on how fiber types might be altered due to training?
So you mean the agreement between the biopsy-based methods and the non-invasive ones? Or
yeah, for example, or is there anything for the non-invasive methods that you have studied that you definitely want to add in this episode?
Yeah. Well, we've, like from the survey that was done in all these more than 400 coaches, what the coaches said they were using, because 50% of the coaches said, we're using or we're measuring or estimating fiber type composition. The most common method was just by their experience, which, I mean, you could make a good guess, I don't know, but you could also make a wrong guess, I suppose. And then the second one was the jump tests that they used. And for example, from my study, I saw that there was some relationship between the jump height and the fiber type composition, but it was a really moderate one. So if that's then that's one of the most common methods used by the coaches, but maybe it's, I mean, or it is not the best one, probably.
Mm-hmm.
Yeah. And then, lactate post-Wingate was one of the better indicators of fiber type composition in my sample.
Yeah, I think one thing that I've always heard when muscle fiber types are involved is that having a percentage of the muscle of the myosin heavy chain does not, I guess, always translate to the overall function. So the function of the muscle is, I think, what is most important, because it translates to the performance. And this is one indicator, but I think it's important to mention that this is just an indicator that we can use, because this is one of our tools of how to characterize the muscle. And thinking about what kind of enzymes are within the muscle fiber, what kind of what is the calcium content in the SR, what kind of enzymes and transporters are located within this. I think this will all correlate with myosin heavy chain isoforms, but I think it's not exactly as it does not exactly translate.
Yeah, that's probably something for the future as well, as there are now newer methodologies like transcriptomics, proteomics, and these omics methods allow you to like capture many more either gene expressions at the RNA level or proteins, and so then I think in the future we will probably move away from focusing so much on the myosin heavy chain, but considering other important proteins for muscle function, for example, as you said, the CERCAS and those kinds of proteins.
Yeah. Okay. So now I would like to come to the final chapter, and having an overview about how can I change my muscle fiber typology. Imagine I'm more that mixture type, and I want to focus more on endurance or more on strength, because this is what I probably need for my sports performance. How can they be changed due to exercise? Because if we come back to the previous episode with Fabian Müller about space research, he mentioned that they in space, if they have long-term missions, they have obviously no loading or almost no loading. So this is why I looked at the study of Wigner and colleagues from 2020.
Okay.
A systematic review of how inactivity alters the fiber type distribution, and they mentioned that the percentage of type 1 fibers goes down, so it declines, and the percentage of type 2 fibers, especially type 2X fibers, increases if we take a look at the cross-sectional area. But how can I change my muscle fiber types with different types of training? Is there evidence, or is there rather a controversy?
There is a controversy, or there's quite some debate on if, like the first question you ask is, can muscle fiber types change in a human being? And if so, to what extent? And as I mentioned before, I think there's a genetic base, but then there's some wiggle room to probably change it as well in some direction. The problem is to give clear answers on these questions. You would need like long longitudinal studies with probably a few biopsies in there. And with the variation of the measurements, if like you would need large changes or large effects to actually pick those up from the results. So that's probably why there's controversy around it, because it's hard to come up with really hard evidence from it's like this or it's like that.
Because when I started studying sports science, there was this rumor, or it was this myth about the rumor that I can change from type 2 fiber to type 1 fiber, but not the other way around.
It's actually the opposite, actually, because the change that is well documented is from 2X to 2A. That's quite well documented with doing endurance training or resistance training, that you will decrease the type of 2X or hybrids type 2A, type 2X fibers, which they would most likely be, that you would decrease those hybrids and you would increase your type 2A fiber type percentage. The change from type 1 to type 2 or type 2 to type 1 with just regular training, there's less evidence for that one. Some studies find some increases or decreases, whereas others don't really find it.
I think the main problem is that if I take another biopsy, I'm not measuring the exact same fibers to see if these exact same fibers did change. It's always you have always this variation that I have another set of fibers, and I assume or I hope that in some the average should shift, but given the difference between sides and the variation in it, I can imagine that the amount of effect that you need in order to be like twice or 3 times the size of the variation that is without training, is quite
you would need a lot
challenging.
of people to find that on average. It's really changing. And usually, or what you would expect is that it takes some time for fibers to actually change. And then, one hypothesis of the function of these hybrid fibers is that they're like a pool of fibers that can change, or a pool of fibers that have changed from a pure fiber to a hybrid one. Yeah.
Okay. So, but is it within this debate? Is it a well-established argument that from a pure fiber to an intermediate, this is well established, or is it just a concept?
Like
so that you, for example, can't change from a pure type 1 to a pure type 2, type 2X, but you can change to an intermediate.
Probably, yeah. Especially the type 2A to type 2X is quite well established. For example, there's one study by a group in Copenhagen by Jesper Andersen and Per Agard already from, I think, more than 20 years ago. And they did biopsy pre-intervention. And then there were some 2X fibers, with the ATPase method. And then they did training, resistance training for 3 months, and type 2X percentage decreased to almost no type 2X fibers anymore. And then they did 3 months for detraining, like no training at all. And the ATPase determined type 2X percentage increased to higher levels than pre-training levels.
Oh.
So the inactivity or the detraining increased the type 2X percentage, based on this ATPase method. Yeah.
Okay. Yeah, so there's still ongoing research on fiber shifting and changes, and it's still an ongoing debate. Besides some things that are considered to be proven, and other things that are not proven. What I was wondering is, so when I want to, for example, increase my speed, I think I'm always limited by the constitution of my nervous system, because, for example, if I have very high motor units, so really thick nerve fibers that are quite fast and innervate at the same time a lot of muscle fibers, this is probably also a genetic predisposition, and I assume that changes on the muscle level are easier than compared to the nervous system. So in other words, if I'm from my birth have not the constitution of large motor units, large muscle or nervous fibers, I think the shift in muscle fibers is probably limited, but the other way around, having a thick cable or a thick nerve fiber and just firing slowly, maybe comes to this rumor that I can go from sprinting to endurance more easily because I'm not limited by the maximum velocity of the nerve fibers and not the other way around. But
so it's true that it's actually the motor unit that determines also the fiber type, like all innervated fibers from one motor unit or from the same type. And one interesting classical study that they did was having different muscles of cat, and then there was one fast muscle, one slow muscle, and then they changed the nerves from one to another, and then the characteristics of the slow muscle changed to the characteristics of the fast one, and vice versa. So it is true that like the innervating nerve is really important for fiber type as well. And I'm not sure about it, but I think I would agree that it's hard to change your nervous system to some extent. Yeah.
Yeah, and probably even if it changed, not to the degree that the muscle can adapt to training or the period of time that is needed to, let's make 10% changes. But on the muscle level, it's probably way shorter period of time to have these changes. But still something that future studies and future coaches should take a look at of how this might change or the percentage changes.
Yeah, the studies I'm looking forward most, or that I find really interesting, are the ones where they characterize fiber type composition, be it in, I don't know, with biopsies or another non-invasive method. And then they look at the training responses, like the study with the middle long distance runners, that they saw, these are more prone to fatigue after an overload period, because I think those have real implications for coaches. If you know the fiber type composition of your athlete, you already know how to manipulate your training variables. Whereas if you want to, if a new athlete comes to you, you probably need some time to know this training method works for this athlete. You probably need a few years, but maybe if you would have known their fiber type composition, that could have already put you in the right direction. So I really like those training studies where they characterize fiber type composition beforehand and then look how they respond. My colleague Kim van Vossel, who recently finished her PhD, she, for example, did a resistance training study. So she characterized the participants based on the MRI-based method, and then had a group of slow typology and fast typology people. And she wanted to see if the same training program, they went to failure on each set of resistance training exercise, if over the course of about 10 weeks, if those fast typology group would increase their muscle mass more or their muscle strength more than the slow typology group. And it was not the case. There was no difference in muscle mass accretion between the two groups. The only difference was that the slow typology group, since they went to failure each time, they executed more repetitions over the course of the training period, because the thing that was fixed or standardized was you have to go to failure with this percentage of your 1RM. And the slow typology participants were just able to do more reps with a certain percentage of their 1RM. So you could say, maybe the slow typology individuals need more reps at this percentage to get to the similar extent of muscle mass gains as compared to the fast typology participants.
Wow, really interesting. And we see that it is really bridging the fundamental research about typology percentages and what I exactly do for the training on what percentage of 1RM I do the training. So I think that's a good wrap up for this this section. I would like to give a short summary of our 4 questions, and afterwards I would like you to maybe, if you have an idea of or an advice for coaches from your research or from what you found, what would you say is like a key message maybe you have? And I give you a little bit of time while I give a wrap up. So we learned that we have basically 3 different types of fiber: the slow ones, type 1, and the fast ones, type 2A, type 2X, and the intermediate versions of it. They are related to exercise performance in a way that different sports have different compositions. There's still a lot of variation even within different kinds of sports, but it translates to the training and might also translate to the recommended pacing strategy as well, which is quite interesting for me. We learned that the muscle fiber typology can be determined by various methods and that the methods matter, so that they agree to a certain extent, but they have all disadvantages and advantages. Some are more costly or more take more time. Some are can be more easily applied, but are just an average, for example. And that if I read certain percentages, that I always have to take care of what kind of methods was used. That is important. And we had a brief discussion about how muscle fiber composition may change due to inactivity. You mentioned that a change due to inactivity, that the type 2X content increases, seems to be quite reasonable. And for the training that it doesn't matter what kind of training, endurance training or strength training, that the somehow shift from a type 2X to type 2A seems to be proven, but for the other changes, it was not that easily to be detected, and there's still an ongoing debate. For the end of this episode, do you have a certain key message that you want to apply, or a certain statement for maybe other coaches or other researchers, athletes, something that stuck to your head while you made all the research?
I think one main message would be for coaches to try to profile their athletes. I'm working mainly on muscle fiber type composition, but I think you could also measure different parameters, anaerobic speed reserve, different parameters to profile your athletes and try to see what works best for those type of athletes, and don't train all your athletes in the same way. Try to find out what works best for the one and for the other, and usually those parameters will help you in seeing which method is best for which one. And I hope at the end of my PhD that I can give some more insights in which methods are best for investigating or estimating fiber type composition, and then you can use those methods.
Great. I think this is a great key statement. So not one size fits all, and individualize the training based on, first of all, individualize, and then maybe one of your methods.
And maybe measured parameters, objective parameters can help in how to individualize your athletes.
Great. If people that are listening to this podcast, Exercise and Set Out, want to know more about your research, how can they get in contact with you? You have a profile on ResearchGate where one can find your research articles and your contacts. What other channels can be used to get in contact with you? ResearchGate is one. I also have a Twitter account, and then just by email. Freek.van-de-Casteele@ugent.be. Okay. What is the name of your accounts if they want to get
the Twitter one?
Yeah.
It's @ and then Casteele, so CASTEELE, and then Freek, so FREEK.
Okay, great. Okay. And what are your next steps? Finishing your PhD, writing the last papers?
Yeah, so all my data is collected.
Which is great.
Yeah, which is really great. So it's mainly analyzing data and writing up manuscripts, hopefully publishing them, and then hopefully submitting the thesis somewhere at the end of this year, the beginning of next year. Yeah, that's the plan.
I say fingers crossed for everything. I have no doubt about that you will finish this really good. And there's still a life after a PhD. I can say I think I'm 4.5 years out of the PhD. But I think you can do this. And yeah, I wish you all the best for the last steps of this journey. Thanks again for your time. It was really nice having you around here in Cologne and having a chat with you about muscle fiber typology. It was your second podcast episode. Thanks for being here and talking about your interesting research.
Thank you for having me. It was my pleasure.
Yeah, great. Okay. For in the next episode 23, will be the third part of our hypoxia sessions. We talked about hypoxia in the hypoxia training, altitude training in 2 previous episodes. And in the next episode, we will talk about the more applied stuff. So it will be on how to individualize the training within the camp. How does new training and supplementation work on it? And to make the trilogy of altitude training work out. My name is Oliver Quittmann. This is the Exercise Inside Out podcast, and see you around next time. Bye.